In this video, I'm going to show you how you can run llama.cpp with Deepseek R1 weights on Milk5 Pioneer box or any RISC-V compute machine. If you go to the llama.cpp repository and you scroll down, you will see the models that are compatible with llama.cpp, and you can get the weights from the link that they have already posted here. So if you scroll down, you will see the Deepseek is also listed here. And on this page you will see that there are a number of weights that you can use with llama.cpp. For this video I'm going to use the Deepseek R1 weight, which is 1.5 which is with 1.5 billion parameters, and it is distill quen, which is over here, Deepseek R1 distill quen. So the first thing that you have to do is that you have to clone the repository on the x86 machine and not the RISC-V machine. Why you need to do that? The reason for that is that you will have to convert the models from Hugging Face format to the GGUF format so that llama.cpp can run that. And PyTorch is currently not supported on the RISC-V, so you will have to clone the model on the x86 machine and then use the script that is included in this repository, and you can use that to convert the weights to GGO format, and then you will have to transfer them to the RISC-V machine where you can run them. So I have already cloned on my x86 machine, and there you can see that there are a number of scripts that they have already provided, and you can use them to convert the Hugging Face format to the GGUF format. And this is basically this script over here. And after you have cloned the repository, the next thing you will have to do is that you will have to clone the weights from Hugging Face to your x86 machine. So if you go to the weight and then you click on these three dots and then on the clone repository, it will show you how you can do that. This will take some time because the model is about 3.66 gigabytes, so it will take some time for the download. So after you have downloaded it, you will have to give the path of the folder. So as in my case, I have cloned it in my current repository folder, so I'll have to just give my name. But if in case that you have placed it somewhere else, you will have to give the absolute path to the weights. So if you run this command, this will also take some time because converting 3.66 gigabytes of weights to the GGUF will take some time depending on the compute power. I'm not going to convert because I already have it on my machine and I have transferred to the RISC-V machine, so I'm going to go to the Milk5 Pioneer box to just execute the llama.cpp. The next thing that you have to do is that you will have to build the llama.cpp on the RISC-V machine. Currently, as this machine, which is the Milk5 Pioneer box, is using the T-head vector extension, and the code gen is not too good for this IS extension, so I am going to skip the RISC-V flag. The other reason is that the RISC-V is supported only for vector extension 1.0, so it will give you the illegal instruction access fault, so it is better to turn it off. And the next thing is that you will have to mention how many jobs you will have to the command has to use to build the llama.cpp. So in my case, I have 64 cores, as you can see in the bottom panel, so I'm going to mention 64 here. The next thing that you have to mention here is that the target that you are going to build. In my case, I am going to use the llama CLI because this is the binary which you will be using for running the weights on llama.cpp. If there is anything else, you can just skip them if the main goal is just to run the weights on the llama.cpp. So it's done, maybe because in my case I already had the compiled binaries, so it did not take any time, but in your case it may take some time to build. The next thing that I'm going to do is that I'm just going to execute the llama.cpp. So in this command, the first thing is that the binary for llama CLI will be placed in the build/bin folder. So I am going to give the relative path from my current folder to the llama CLI binary. The next thing that I am going to do is that I'm going to mention the path of the weights. Basically, the ideal thing is that which is the better thing is that you should give the absolute path, but in my case it is pretty simple that I have placed the converted weights into my current directory, so I did not have to give any absolute path. The relative path is good to go. The next thing is that the n mentions the number of tokens. The threads flag basically means that how many threads you are going to use in parallel for this model. In my case I'm not going to use the vector extension, so using as much core as I can for this model is the most sane thing here. So I'm going to use all the cores, so I mentioned 64. The other switch is the no conversation switch. This means that the model will not go into the conversation mode where it will ask you for another prompt. There will only be one prompt, and the prompt is mentioned over here, which is just a simple question, how are you doing? So I'm going to run this. So the tokens have already finished. So if you check this out, the total time it has taken is about 30 seconds, and the tokens per second score is about 23 tokens per second. So this is the score on the Milk 5 Pioneer box without using any vector extension. So this was all about the llama.cpp running on the Milk 5 Pioneer box. Maybe in the future I will be able to run on all the RISC-V boards, and I will post the video about this. So if you have any questions, you can leave in the comments, and you can also like and share the video if you like.